video, we'll be looking at a problem based on distance and time. Both P and Q are crossing a lake along the same routes at constant speeds. Both P is initially behind both Q, and at 4 p.m. both P crosses and overtakes both Q. Both P has a speed 1.2 times that of both Q. At 5:45 p.m. both P reaches the other side of the lake, and at the time both Q is still 70 kilometers away from P. Find the speed of P. Okay, so this is not a simple question. This involves a lot of critical thinking skills. Let's first look at the problem. We can see that there are two boats, P and Q. They are crossing from one side of the lake to the other side of the lake. Now, they both start off at some point, and the question states that at 4 p.m. both P crosses and overtakes both Q. Before that, both P is behind both Q. Now, the speed of both P is 1.2 times that of the speed of both Q. Okay, so we have to only concentrate at 4 p.m. and afterwards, because the time before that does not matter. There's no information given about the time before that. So this is at 4 p.m. And what happens at 4 p.m. is that both P crosses both Q. Now the question states that both of the boats cross each other. So what does that actually mean? It means that at this particular time, P and Q are at the same spot. If they're crossing, then they have to be at the same spot, and then one of it has to leave faster, right? So at 4 p.m. P and Q are at the same spot. Afterwards, both P has a speed greater than both Q, and at 5:45 both P reaches the other side of the lake. So this is at 5:45, the position of P. And what happens to both Q? Both Q is still 70 kilometers away from P. So we don't know where on this line both Q is, but it could be somewhere here. And this is at 5:45 p.m. And the distance between P and Q is 70 kilometers. Now with all of this information, also it's given that P speed is 1.2 times Q. Now with all of this information, we are supposed to find out the speed of P. So how do we proceed with this problem? Now let's look at these two critical timings. At 4 p.m. they meet each other, and at 5:45 p.m. both Q is at this spot and P is at the other side of the lake, and the difference between them is 70 kilometers. So in order to find the speed of P or Q, what do you need? Let's just say I'm finding the speed of both Q. What will I need? I will need distance by time. What is the time taken from this spot? Q was originally at this spot to this spot. What is the time taken? It is 1 hour 45 minutes, because it's from 4 to 5:45. So the time will be 1 hour 45 minutes. Now we can write 1 hour 45 minutes as 7/4 of an hour. Why? Because this is actually equal to 1 hour plus 45 minutes will be 3/4 of an hour. So this will give us 7/4 of an hour, right? So we can write this as 7/4 because everything is in the form of hours over here. Now what about the distance? Do we know the distance that Q has traveled from this spot, from this timing to this timing? From 4 to 5:45, do we know this distance? No, we don't know that. The question has not given us anything about the distance which has been traveled by Q from 4 o'clock to 5:45. So we don't know the distance. We can't find the speed of Q. Let's look at the speed of P. It's distance by time. The time again would be from 4 to 5:45. So it's 7/4 of an hour. And what about the distance? Do we know this distance? We don't know that distance. The distance is not known in the problem. So how do we proceed with such a problem? We can't find the speed of Q or P. The only thing that we know is the difference between the distance between P and Q. The difference in distance between P and Q is 70 kilometers. So instead of finding the speed of Q or P, let's find relative speed. We'll be finding relative speed. What is relative speed? Relative speed is the difference in speed of P and Q. The difference in speed between P and Q is called as relative speed. So the relative speed formula can be written as difference in distance by time. So what is the difference in distance? At the same timing 5:45, P has travelled at this time interval 4 to 5:45. P has travelled 70 kilometers more than Q. Right? So this will be the difference in distance, 70 kilometers. So the difference in distance is 70. What about the time period? And that is 7/4 hours. Because this difference happens in 7/4 hours. 1 hour 45 minutes. Okay. So now we can find the relative speed between the two boats. Relative speed will be, let's have it as R. Relative speed will be 70 divided by 7/4, and that gives us 70 into 4/7. This is 40 kilometers per hour. Now you should not get confused with this 40 kilometers per hour. This is not the speed of P or Q, but this is the difference in speed between P and Q. Now let's proceed on with the problem. We have found out the difference in speed between P and Q. The question gives us another clue, and that is boat P has a speed 1.2 times that of boat Q. Let's represent speed as R over here. The speed of P is 1.2 times that of speed of Q. So we'll have RP and RQ. This is the speed of P and this is the speed of Q. RP will be equal to 1.2 times that of Q. So 1.2 into RQ. Now RP will be equal to RQ plus 0.2 RQ. Can this statement be written as this? Yes, because 1.2 can be divided into 1 RQ plus 0.2 RQ. So this bit is actually the difference in speed between P and Q. Right? Difference in speed is RP, speed of P minus speed of Q, and that is equal to 0.2 RQ. Now what is 0.2 RQ? We have found out that the difference in speed is 40 kilometers per hour. This is the difference in speed. So we can equate RP minus RQ is equal to 0.2 RQ, and that is equal to 40 kilometers per hour. From here onwards, we can solve it easily. 0.2 RQ is 40 kilometers per hour. So the speed of Q will be 40 by 0.2, and this gives us 200 kilometers per hour. So now we have found out the speed of Q. Things become easier after this. The question wants us to find out the speed of P. if Q travels at 200 kilometers per hour and P is 1.2 times the speed of Q, then this is actually equal to 12 by 10 times that of 200, and this is 240 kilometers per hour. So this will be the speed of boat P. So you can see in this problem we have dealt with relative speed. We don't know the individual speeds because there's no info given about that in the problem. So we have taken the difference between the speed of both of them and we have found out the answer.